So very quickly, in engineering, we don't typically just have one device in isolation. We don't just have a turbine or have a boiler or whatever. What we have is a combination of them that's set up what we call a cycle, okay? And then from that cycle, we get some work out or we get heat out or something like that. But basically, it's a combination of these components to achieve some objective. Like right here, I have a power cycle, right? So I heat the steam up, put it through a turbine, use that high energy steam to get work out, right? Dump some of the heat before throwing it back into a pump to raise the pressure back up and put energy back into the steam, putting it through the boiler, right? So you go device by device, calculating the work of the heat as discussed in the previous lecture in order to get some objective, okay? Now, the basic way to solve these is you find the enthalpy for each state, basically between each of the devices, right? So I've got 4 different states. You go through, you find your H values and use the tables, okay? 9 times out of 10, you're going to look up H values in the tables, okay? So once you have those, then if needed, you go ahead and you find your mass flow. Either you know the volumetric flow, or let's say you know the work of the pump, so you can use H on either side to determine the mass flow. Okay, sometimes you don't need it. They say, hey, just find this in terms of mass. Okay, so but generally you need to find that mass flow next. Then basically for each component, you find your work, or you find your heat transfer, or both. And a lot of times with these, take, for example, the pump and the turbine are usually adiabatic, so Q is 0. The boiler and the condenser have no work, so basically it's either Q equals delta H or work equals delta H. Again, just depending on the device and what you know about that device. So this is the general approach to solving these cycles with, fluid flow happening between devices.